Welcome to lecture 4.3. You know what I said in 4.3? I was going to discuss the McFadden setup. I forgot to do one little thing, so it'll be 4.4 where I discuss the McFadden setup. Let me do the one little thing, and this is that what we say is before, so epsilon t is distributed standard logistic, then probability epsilon t less than or equal to z, CDF just equals e to the z divided by 1 plus e to the z. Okay. One little thing I wanted to show you is that we often is this convention. For logistic, often we define capital lambda of z, I'm going to use the 3 equal sign, is defined to be e to the z 1 plus e to the z. Okay. Learn that. You have a homework problem where I said, well, if that's the CDF of the logistic, what's the PDF? Well, the answer is you take the derivative of that, and then you're supposed to show that, I'm almost certain I remember this right, the derivative of that you can prove equals phi of z times 1 minus, lambda of z times 1 minus lambda of z. Okay, so that's a homework problem. Just a little calculus problem. Well, you could probably do it. It's probably from your freshman calculus, so it should be easy. So we have that. Okay, now one thing we'll use, given this notation, let me go back to one where we did our likelihood function. So this was the problem where, so there was a logit, the dependent variable was 3 cases. Dependent variable is 1, 0, 1. Here's what the likelihood function looks like. I said there was only one independent variable, x, plus a constant. Given our notation, or given our convention of that big lambda, we can rewrite that likelihood function. It just equals big lambda of beta 0 plus beta 1 x times 1 minus big lambda beta 0 plus beta 1 x1, that's x2, and then times big lambda beta 0 plus beta 1 x3. Okay, so all I wanted you to see is that there's this convention of what big lambda means. If I use that convention, I can rewrite that likelihood function a slightly different way. Okay, so I just want you to get a little bit used to that convention, what big lambda means. Okay, that's all. Okay, so that is 4.3. 4.3. See you in 4.4.